All right. Here we are, week 19, part 1. And we're going to start this off. We're dealing with fractional exponents in this lesson. But if we have this table for our reference, it should be helpful. So in the top numbers represent the exponent, and these numbers represent the base. So for example, 1 to the first is 1. 1 to the second is 1, 1 to the third is 1, 1 to the fourth is 1, etc. Down here, so if we were looking at 8, for example, 2 to the third equals 8. 2 to the third, I need a bigger marker, equals 8. Okay. If we were to take a look at this, the 625, we could say something like, or that is 625 because 4 to, did I say that? No. Yes. 5 to the fourth equals 625. So 5, the base, to the fourth equals 625. These I left blank because those are really big numbers, and you might want to fill those out for yourself, but it's pretty unlikely that you would see these in a question or be expected to know that. You know, you could always use a calculator to figure those out. So you might want to use a calculator and fill those in just for fun. But the other ones, these are numbers that you'll see frequently and so should be kind of familiar with. Okay, so using that, let us apply that. So these first instructions say evaluate the expression without using a calculator. So it's kind of cool that we have 25 to the 3 halves, and it sounds weird, but if we think of 3 halves as 1 half times 3, okay, so 3 halves is the same as 1 half times 3, and we use the fraction as the exponent first, we know that this to the 1 half is the same thing as taking the square root. So 25 to the 1 half is the same as the square root of 25, which is 5, and then we have that to the third, and so thinking about it or looking at the chart above, 5 to the third equals 125. Okay. And you could verify, if you were typing this in on your calculator, just to get familiar with the calculator or to check your work, you'd probably want to say 25 to the, and then make sure you put that 3 halves in parentheses. If you were to just type in this, 25 to the, and then 3 divided by 2, it would give you some huge number. The calculator would do this first, 25 to the third, and then whatever that answer is, it would divide it by 2. So that would be incorrect for typing it into the calculator. This would be correct. Okay. Number 2, so we have negative 64 to the 4 thirds. And this, here, because we have a negative base, the odd and even roots and exponents are coming into play. Odd number meaning 3, even number meaning 4. So we have negative 64 to the 1 third. Notice how I put this in parentheses. It is the negative 64 to the 1 third. And because a negative times a negative times a negative equals a negative, this is why the cube root of negative 64 is negative 4. We then have that to the 4th power, so multiplying a negative by itself 4 times gives a positive, and 4 to the 4th is 256. Number 3, so let's see, 8 to the negative. So here, instead of the base being negative, we have the exponent being negative. When the exponent is negative, we bring the whole thing, meaning the base, down, or we move it from the bottom to the top, and we turn the exponent into a positive. So negative exponent is the same as underneath, or up above, and positive. And then we can treat this just as we did before, where it's 8 to the 1 third, and then squared, so 2 thirds is 1 third times 2. And we know that 8 to the 1 third is the same thing as the cube root of 8, which is 2, and then we have 2 squared, so this squared is this, giving us 4. So the answer would be 1/4. Number 4, Similarly, a negative exponent. So we bring that down and call it 16 to the positive 7/4. 7/4 we're writing as, so 7/4 is the same as 1/4 times 7, which is where this stuff comes from. So we have 16 to the 1/4, and that would be 2, and then 2 to the 7th would be this. Now, right here, this could technically, when we do this, the 4th root of 16, it could be plus or minus 2. And then if that were to the 7th, it would give us plus or minus this. And so, yeah, maybe this would be more appropriate, saying plus or minus 128. The answers in our book are basically, if we have this type of situation, they're going to be using just the positive root. And so would say something like this. But if you were to put this, that's definitely not correct. When you take an even root of a number, you technically do end up with a plus or minus. All right, so let's take a look at page 2. And instructions say find the real solutions to the equation rounded to decimal places when appropriate. So when you do these in your homework, some of them you will be using calculator round to 2 decimal places. For example, if you had square root of 11, that you don't know in your head, it can't be simplified, but you could find a decimal value. I think all of these ended up being all the examples that I chose we could do in our head, but let's see. So first, we want to get the variable by itself, right? So we're going to divide both sides by 5. This looks familiar. Okay, look at page 1 of the notes. And so to move on, at this point, we would take the cube root of both sides. You could also say, because it's the same thing, that what we're doing is we're raising both sides to the 1/3 power. And so do you see how 3 times 1/3 is 1, giving us just x, and that's what we're looking for. To get rid of the exponent of 3, we take the cube root. So the cube root of 216 could be written this way or could be written this way. You don't have to write both. I wrote them just for fun. And the cube root of 216 is 6. All right. Questions? Well, hard to ask questions of a video, but okay, here we go. Number 6. Real common mistake. People would do 2 minus 6 and get a -4 right there. No way. This is being multiplied, so first we need to get rid of the 2. That is a positive 2, so we're going to subtract 2 from both sides. So this leaves us with -6 x to the 4th equals -96. Then dividing both sides by -6 gives us x to the 4th equals 16. And looking on our chart from page 1, we see that 2 to the 4th equals 16. So to move on from here, we in essence are raising both sides to the 1/4 power. We could also say that we are taking the 4th root, and that could be written like this. We are taking the 4th root of both sides, giving us, and so I put the plus or minus in there. Again, it's an even root of something. And so we could end up with plus or minus 2. So if you were to plug in -2 there or +2, both would work in that equation. Number 7. So we're trying to get the x to the 6th all by itself, so I'm going to subtract the 36 from both sides, and we get x to the 6th equals 64. At this point, we again are raising both sides to the 1/6 power, and this would give us, again, it's an even root, so we end up with a plus or minus 2. And just for the sake of example, if we had this, okay, x to the 3rd equals 27, for example, and we were to take the 1/3 power, or the 3rd root of both sides, we would just end up with x equals +3, not plus or minus, because this is an odd root. It's only true with even roots that we end up with a plus or minus. Okay, number 8. So to get rid of the 1/3, I'm going to multiply both sides by 3. That's what this is here. But it'd be like times 3 and times 3. So we get to this place, and then I'm going to take the 4th root of both sides. And again, that's an even root, so I'm going to get plus or minus 3, because 3 times 3 times 3 times 3 equals 81. Or in other words, 3 to the 4th equals 81. Or in other words, 81 to the 1/4 equals 3, plus or minus. Okay, thanks for listening.